Bye.
And today we will be talking about our internship that we got through the Met Professional Academy at the City of Peoria. So, just a little insight on how this internship worked. For the first semester, on Tuesdays and Fridays, we worked on our internship, and on Fridays, we went to the Traffic Management Center at the City of Peoria and worked with professionals like Steve McKenzie, Jody Brayfogle, and Chris Lemke, and we learned so much. So let's get started. First of all, how do traffic signals really work? Well, let's break it down. Let's look at the components. We have CCTV cameras and video detection, 3, 4, 5 section heads, which you've all seen, the traffic cabinet, the vault, the pedestrian push buttons, and pedestrian signals. Let's look at the cameras. So, what do CCTV cameras do? Well, basically, it provides the people at City of Peoria to monitor every single intersection, whereas video detection is used to track cars, and both of these cameras can be used for adaptive systems, which I'll go more into later. Alright, so this is a traffic cabinet. Now when we all saw this, we had no idea what we were looking at. There's a lot here, and now that we know it all, let's break it down. First, you have the power supply unit, or the PSU. What this does, it supplies power to the cabinet, pretty self-explanatory. Then we have the controller, which is like the brains. Then we have the NMU, which is that double check, which I'll go more into later. Then we have the bus interface unit, which just sends those signals to the traffic signal. It says, hey, green, yellow, red. Then we have the switch, which transfers data. Then we have adaptive systems. Like I was saying earlier about CCTV cameras and video detection, adaptive systems uses that to change the signal timings in real time. So it says, oh, there's congestion on the eastbound and westbound. So let's change the signal timing so that we can clear that congestion. Then we have the daylight sensor, which detects daylight or no daylight and just turns on or off the street lights. Alright, the traffic controller. Like I said, it's the brains of the traffic cabinet. Basically what it does is it creates those signal timings for the traffic signal, and signal technicians can go out in the field and manually test things. The NMU, like I said, is that double check, it's the fail-safe, so it sees what the controller is doing, and it has to pass through the NMU, and it says, oh hey, you can't have that, you can't have two opposing greens, I'm sending the signal into flash. And what signal technicians can do is they can go out to the field, look through the history of the NMU, and see, oh hey, we have a dual indication, like that, and they can diagnose that problem and get that signal out of flash. Then we have the switch. Basically, all the devices in the traffic cabinet connect to the switch, and then from there, the data is transferred to the traffic management center through fiber optic cables. But before that happens, we go to the vault. This is where incoming and outgoing fiber optic cables are spliced together in a splice enclosure. Here's what the internals look like, and basically what this does is just connect the fiber optic cable so it can flow through it seamlessly. So what is fiber optic cable? Basically, it has a glass core where light waves transfer through it to transfer data, and cladding speeds that up, coding keeps it all in, as well as the strength. And then from there, all that data goes to the traffic management center.
So, the TMC, for those of you who don't know, it's the Traffic Management Center. It's Peoria's main traffic hub, and that houses all the data storage that is collected from all the intersections and the cameras that are present there. It also has the traffic software that I'll be talking about later, and real-time surveillance of all the intersections that are happening at the same time. Jody and Steve, when we went over it, we were able to see vehicles and their collisions and how it happened in specific areas. We saw people jaywalking. But it allowed us to really survey what are intersections like as you're actively seeing them. And that was incredibly useful for our own education, and it's useful for the traffic engineers who are working there every single day. The TMC servers have 96 hours of surveillance footage. They use this in coordination with the Peoria Police Department. If there's a vehicle they need to find, they can coordinate with it. And it also allows traffic engineers to diagnose if there is a vehicle collision, what exactly happens in the events up to it. And you can see the beginnings of when the signal cuts out, when the cabinet gets destroyed. The servers also handle the storage of all the traffic counts. It's incredibly important to have traffic counts because then you don't have to send someone out there with a clicker all day, clicking monotonously the entire time. It eliminates the failure of human error when you're clicking that long, and it's just much more accurate. The TMC servers are also used to model congestion levels of service through software such as Synchro and IMSA. So Synchro is a traffic modeling software, and it's a very useful visualization tool. When we started learning, it's very useful that instead of just looking at like a plan set like you might have had to do 20, 30 years ago, you can have a nice visualization tool of here are the vehicles traveling in this area, here's what they look like from an overhead view, here's the data put into it. And it allows you to really see what you're looking at. It also gives intersection recommendations, for better or worse, but it allows traffic engineers to see, do we want to make something more efficient, or do we want to make modifications and changes, and it kind of allows you to have a level of flexibility. It also calculates traffic timings and then traffic flow and offset. So GridSmart is currently the software that is being used to detect vehicles. As you can see here in the video, when vehicles are passing into this black rectangle or square, it lights up blue and tracks that a vehicle is there. This is the majority of what it does, and it notifies the controller that a vehicle has passed through. This can be used in utilization at the TMC with other softwares and equipment, such as the adaptive systems, to help extend or remove wait times in other directions if there is no traffic. Signal timings are incredibly important to maximize efficiency. Not at the cost of safety, of course, but if people are able to get through efficiently, they're not going to be doing rash decisions such as purposely running a red light when everything's stopped if they think that there might be a chance. All of the signal timing is adjustable through software at the TMC, such as through Synchro, and it's dependent on volume, traffic flow, and the main road that it's focused on. It all is dependent on what intersection are you looking at, how do the vehicles interact, and it's incredibly useful for it to all be there. Clearance timing is the yellow timing that is determined by the speed of the cars. If vehicles are traveling 40 miles an hour to 45 miles an hour, we want to increase the time because they are traveling faster in a specific area. We want to make sure they're getting through safely, especially if they entered legally on a yellow. All red time is determined by the size of the intersection. If someone enters on a yellow, you want to make sure that they're able to safely get through, because you do not want to have a vehicle that is trying to get through at the last possible moment, and that moment of no return where you decide, are you going to brake or are you going to keep going? And then there's another vehicle that sees the green, goes forward, and they collide. You do not want that to happen. So, next thing that I'm going to be talking about is time-space diagrams. When we first saw this, no idea what was happening. For a fun experiment, I showed it to some of my classmates at that, and they just had no idea what was happening whatsoever. So I'm going to help go through it. Kind of the process of what we learned. It took us about a week going over this twice for us to really understand. So time-space diagrams is a useful graph to track the vehicles through the data output that you put into Synchro. The street names are on the left, and the Santa lines represent cars. The blue lines are vehicles coming from the north in the corridor, and the red lines are coming south. Horizontal lines are the traffic timings, so the green, yellow, and reds, it signifies traffic timings, and the lights that vehicles will be seeing. And then clump lines represent congestion. This is a nice model because you can see if they start stacking, then they are unable to get through the intersection, or they're having a hard time getting through during that period of green light. So you can notice, are there too many vehicles at that specific time? Is there a ton of traffic at this specific point? You can see that all when it all just goes sideways. Next is Synchro design and levels of service. So it takes the data input into Synchro and then assigns it a letter grade. The letter grade is determined by the amount of delay. A grade is minimal levels of delay. So if you have a high flow road, then you would give it an A. And then if there are other opposing roads that are minor, then you would give it a lower rating because it would have larger amounts of delay. And this can also be heavily used with adaptive systems to determine which specific area has more priority and has minimal levels of delay compared to an area that would have more. This is clever. Okay. Levels of service can be seen here through different types of grading, and then also the different delays that can be shown with that too. Next, Avery is going to be talking about traffic studies, which is what we focused on during the second semester of our internship.
Christian mentioned, our second semester we were working on traffic studies with Chris Lemke, where we were working on a fictional TIA. So a TIA, otherwise known as a traffic impact analysis, are reports that traffic engineers design to analyze the impact that different developments will have on surrounding traffic and to mitigate any problems that these developments will bring upon. A TIA is usually created when you need to rezone a parcel of land. For example, if you want to build a McDonald's where the land is zoned for residential, you'd have to go to the government and go through a whole process in which a TIA is a part of. And a TIA just ensures that traffic is safe when the project is implemented. And as you can see on this slide, the red star indicates the location of our fictional TIA, which was the northeast corner of Lake Pleasant Parkway and Deer Valley Road. Zooming in closer, we have the site plan for our TIA. We were analyzing the impacts of the mid-rise apartment building, a McDonald's, and a Red Lobster. All of these have different land use codes, so they will all have different impacts on the surrounding traffic. And we utilized 2 different manuals throughout this semester, which was the first one being the ITE trip generation manual. This is where we got our formulas to estimate the amount of trips generated by each new development. And our second manual was the TIA Access Management Standards by the City of Peoria. This is used to figure out what category our TIA was a part of. This table is straight out of the Access Management Standards. It turns out our TIA was category 1. This is because for the highest peak hour, the amount of trips was in between that 100-500 vehicle threshold, which means we had to study for the opening year and 5 years into the future. Moving on, we have our trip distribution CAD model. This is just how we distributed the trips for each direction, and we got these percentages by using the 2023 existing traffic volumes from the City of Peoria government website. And for the driveways, we had a 70-30 split. This is because for the 70% driveway, it was closer to Liberty High School, so it will experience higher traffic volumes. We then combined our trip distribution and our trip generation, and this is how we got our trip assignment. This is how we assigned those trips generated into different movements for the intersection and the driveways, and we did this for each scenario. We then implemented these scenarios into Synchro, and for each scenario we got different results, but it came in like this very confusing model, but we then simplified it down to a table which shows the LOSs and the delays for the peak hours for each scenario. When we analyzed these different models, we figured out that we only needed 1 mitigation, which was to remove the left turn out of the driveway connecting to the southbound plaza. This was because it was at an unacceptable LOS of below D. So by removing that left turn, we had to distribute those volumes elsewhere. So we put those volumes into the right turn out and to the incoming intersection for U-turn as an alternative to the left turn. And when we added those volumes, it didn't negatively impact the LOS. When we combined all these components into our TIA, our report came to be about 60+ pages. So to wrap this all up, we're gonna go over our personal experiences. So for me, getting into this internship, I already knew I wanted to get into traffic engineering, but getting these hands-on experiences and the foundation of traffic studies, it really grew my passion for this field. So that's why I'm pursuing a civil engineering degree with ASU, and I'm excited for what the future holds before me regarding classes, internships, and my future career.
Yeah, for me, I was hesitant to do this internship at first since my main focus is on mechanical engineering, but through some convincing from Ethan Lemke and Chris Lemke, I thought about it and I was like, where else would I get such amazing experience at the high school level? So I did it, and I am so thankful I did do it, because not only did I learn about a lot of really cool stuff in ITS, but I also learned what it's like to be in that workforce environment and be working with actual professionals.
Okay, so I've been interested in engineering for the majority of my life, and then I got to high school, I did the engineering classes there, and I was kind of just left feeling disappointed. And it didn't make sense to me. I didn't feel like I was learning or applying what I did. And then I went to the Met Professional Academy, which is where I got my internship with Chris, Jody, and Steve. It has honestly been amazing for me. I've been able to rediscover my love for math and engineering and figuring out exactly what to do using design thinking to help others or design a creative, innovative solution. And just the experience of being able to go to the TMC, learn whatever it is, working through EtherWAN to determine more of like the ITS side of traffic engineering. It has all been able to positively impact my career in education for the rest of my life. I've decided that I'm going to be going into computer engineering. Who knows? I'll be going to NAU, Northern Arizona University. I've bumped into two of them. But perhaps I'll be focused on creating technologies, and maybe I'll bring myself back into the traffic side for ITS. Nonetheless, this has been a key point in my life, and I am so thankful and grateful to